So we live on the Earth, obviously, and the Earth is made up of a lot of different things. The Earth is one sphere. Obviously, there's one Earth, and that's one sphere. Well, it's an ellipsoid, it bulges slightly. But it's made up of several different spheres. And that's what this is about. The 4 spheres. The lithosphere, biosphere, atmosphere, and hydrosphere. So yeah, enjoy. So the hydrosphere, as you may be able to tell from the beginning, hydro, it's basically all the world's water, all the water in lakes and rivers and oceans and clouds. It's all part of the hydrosphere. Now, there's very little water in comparison to the amount of, Earth. If you gathered up all the world's water into a little sphere, here we go, make a double fist, put it side by side, and so the diameter of that is the diameter of the Earth, and the water would make a sphere about the size of your 2 thumb knuckles. Those thumb knuckles, that's about the size. There's not actually that much, but it's still enough to sustain our lives, the lives of all these, plants and, all the animals. It's enough, and will be enough. And that's what it does. It sustains, that's its purpose. It sustains life. We need water. We need water far more than we need food. And it all travels about the Earth, because it doesn't just stay up in the clouds or in lakes. It moves about in a thing called the water cycle, which you've probably heard of. So the water cycle. Water is in oceans. It starts there, mostly. And the sun heats it up, and it evaporates in a process known as evaporation. And it all condensates into clouds, or the water vapor. And these clouds, they're pushed by wind into mountains, which they can't get over. So they have to sort of shed weight to do so. And so to do that, they rain, or snow. They precipitate, which goes and makes, finds the lowest point and runs down in runoff, back down to lakes and oceans to be evaporated again. There are several little things that branch off of this. For example, water of course feeds plants, and when it does that, it doesn't just go away. Plants give off their own water vapor, which goes up and condenses into clouds along with the evaporation from the oceans, and that's known as transpiration when it comes from plants into the sky. And water also goes underground and travels in underground little channels, I suppose, and that's percolation. And this all comes back to oceans and lakes, accumulation, and the whole thing begins again. So the atmosphere is probably the one we've all heard of, and that's the sky mostly. So the atmosphere goes from ground level up to the ozone layer, about 25 or so kilometers above our heads, which may seem like a lot, but in comparison to the Earth, it's very little. And if you get one of those large globes that you get in British libraries or something like that, those big ones, and you put a coat of varnish over it, that coat of varnish is the atmosphere in comparison to the Earth. So it's extraordinarily thin, but so it's thin enough to let in most of the sun's rays, most of the stuff that comes in from the sun. So it lets in infrared light and normal light, but it also bars away UV light that causes terrible stuff. And the light that does come in, what it does, it gives nutrients to the plants, photosynthesis, and it gives us all lovely tans and stuff. And that's what it does. It's essentially, well, without it we'd all die. Okay, so the lithosphere, or lithosphere, if that's what you want to call it, is basically, well, it's the ground. It's Earth's crust and everything underneath it, all, precious metals, gold, oil. If it's under the ground, it's part of the lithosphere. Now, I want to keep talking about size, because the Earth, well, in comparison, it's massive. So, if you're not at home, go home. But if you are at home, take an apple and slice it in half, and look at it. Look at the bit that you've cut off, and the skin and the apple is the thickness of the crust in relation to the rest of the Earth, which the Earth would be the apple. So it's phenomenally thin, but it's still deep enough that we're never going to get to the bottom of it. This is very, very small in comparison. Now what the lithosphere does is, well, it literally supports us. We stand on it, and it also provides nutrients for all the plants, all essential things like carbon and nitrogen. They can all be found in the ground as well as other places, but in the ground as well. So anything the plants need they don't get from the sun or water, they'll get from the ground. And the lithosphere, or the surface of the lithosphere, is divided into biomes. And these biomes, they're decided on what vegetation there are. So you've got a desert biome where you've got hardy plants like cactuses, cacti, whatever. Or you've got, this sort of tropical, there's a few types of tropical, and you've got polar regions where there's no vegetation at all. And that's the lithosphere. Okay, so the biosphere, the last one. Bio probably makes you think of, life, not those, but life, except it isn't. So why don't we just skip it? We'll skip to myself talking about this. So the biosphere, it is, well, let me show you. So we've got the other three, the lithosphere, and the atmosphere, the hydrosphere, please ignore my terrible handwriting, and then down here we'll put biosphere. And so as I said, the biosphere is not actually life on Earth because there's a fifth thing. It's not listed on the spheres because it actually doesn't have sphere in the name, and it's the biota, and that is all life on Earth. That's all humans, cats, trees, proteins, whatever. That's what the biota is. Now the biosphere, which is what I'm actually talking about, is actually all four of these things collectively. Its actual definition is the surface of the Earth and its organisms, but of course that also means the sky as well. The biota is basically the point of the other three, the hydrosphere, lithosphere, and atmosphere. They all have the point of preserving the biota. Our lives, the lives of plants, anything. And yeah, that's what it does. It's nothing. actually, that's not true. Us, the plants, we help move essential elements such as carbon and phosphorus and nitrogen and all that through, from the sky to the ground to the water. We help move it all through there.
Where do we humans fit in?
Well, we aren't part of the biota, but to be honest, the Earth would probably get along a lot better if we didn't exist. It's depressing, but it's true. Everything would be a lot better, Earth-wise, if we weren't around. Putting all our chemicals and pollutants into the air and things. Obviously, it's not a huge, absolute major big problem of the world going to die immediately problem yet. But all the scientists are telling us that it will happen rather soon. That we shall all fill up the atmosphere and water with things and we'll all die from it. So, yeah, it's a lot better if we're not around.